Let's talk about computation in z-systems when we use a different operation. So for starters, I need you to look at this table and tell me what z-system I am in. I have a green question mark right here and a green question mark right there. So what little subscript number do I use to place right here? I would use a 6 because I have 1, 2, 3, 4, 5, 6 elements. And what operation? Well, I look in that top left corner and I see that it is multiplication. So we're talking about multiplication in z-systems, and can we use our trick? Or how do we multiply? Ew. Alright, well, let's start with some easy ones, like 0 times 0. I mean, I get 0. That's in the system. That should make me feel pretty cool. What about 0 times 5? Well, in real life I get 0. Is that in the system? Yes, so that seems okay. When I do 2 times 4, what would that be? So 2 times 4. Remember, I go to the left side, and then I come across to where 4 is. So what is 2 times 4 going to be? Okay, how would I do that? So multiplication, so 2 times 4. So Johnny added, though. He used the clock. So how could I think of 2 times 4 using addition? Well, what is multiplication? It's just repeated addition. So Johnny's going to go to 2, and then he's going to add 2. Okay, we just did that. Both of those, okay. Then he's going to add 2. We just did that. And then he's going to add 2. Sweet. Oh, okay. So my answer's 2? Okay. Well, cool. So does that make any sense, though? Like, based on that hint and that trick we were just using? So 2 times 4 is 2. But really 2 times 4 is 8, but somehow I'm supposed to get a 2. Does that make sense when operating in this z6 multiplication? Yes, it does! Yes, because I use this number and I subtract in order to get back in the system. Cool. So I could keep filling this chart out. What if I did a 3 times 5? Ugh. I'd really get 15. I know that's not allowed. So I'd subtract by 6, and then I'd get 9. That seems wrong. So I would subtract by 6 again, and I would get 3. So 3 times 5. So I find the 3 on the left, because that's what's coming first. 3 times 5. I go over to 5, and this is where I'm going to enter in the answer of 3 that I just got. Let's check that with multiplication, though. So 3 repeated addition, so 3 plus 3 plus 3 plus 3 plus 3. Or how about this? What if I were just Johnny and I just counted like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Because see, I wanted to count to 15, and where'd I end up? I ended up at 3. That's interesting. So I guess another way to look at this is, so this is the 0 place. 1, 2, 3, 4, 5. This is really 6. This is really 7. This is actually 8. Same thing as 9. This is the same thing as 10. This is the same thing as 11. So this number, this situation, this value is equivalent to 12. 1's value is equivalent to 13. 2's value is equivalent to 14, to 15. Here's 16. Here's 17. I could just keep going all the way around. Interesting. I wonder if that'll come in handy later. There's a reason why I showed you that.